हरिः कन्ना।
So we have converted an image into an array, and then we have plotted that image array as an image. So now let's have more fun. We will apply a pseudo color schemes to image plots. So pseudo color can be a useful tool for enhancing contrast and visualizing your data more easily. So note that point. So pseudocolor is used to enhance contrast and visualize your data more easily. This is especially useful when making presentations of your data using projectors. So their contrast is typically quite poor. So pseudocolor is only relevant to a single channel grayscale luminosity images. We currently have an RGB image. Since R, G and B are all similar, we can just pick one channel of our data using array slicing. So that's what we are going to do. So let's get into the action. So I'm gonna type applying pseudo color schemes to image plots. Done. So now let me do all the steps one more time so that it would be beneficial for you, so you can understand all the steps one by one. So let me write image img is equals to np dot as array and capital image. From this module I'm gonna bring open method, and inside that open method I'm gonna give double quote or single quote and then dot forward slash and tab. So I'll get into the images. Inside that I have two images, picture one and then stink bug. So I'll click on stink bug this time and enter, and then let me print that. So print rep of img, and here is that array. So this array consists of different matrices all together. So let me see. Okay, three. Let me see the size of it first. Oh, it's a huge. Let me check the size. Let me check the dimension first. So image and dim. So 3 dimensions. Now image shape. It's a 375 rows, 500 columns. Sorry. Yep. Sorry. So this is 375 matrices and 500, so total, and then 3 rows that you can find out here. So let me make it just print img, and it's nothing but a sequence of it's a list of matrices together, nothing much. So from here to here this is one section, I think. From here to here one. So it's a huge one, it's a huge one. Then let me go for the image img size. Okay, it's 5,62,500. Clear? So now what I'm gonna do, so we have seen the properties of this image array. So this is array properties of that array. So what we are gonna do, we will plot this as image plot is equals to plt dot imshow and img, and here is that. So now let's add a pseudo color to this so that we can have a contrast, an increased contrast, and so visualization makes easier. So I'll make a lum underscore image, and then image of obviously it's a 3 dimensions, and it's 0, and execute. So nothing, because it's just a variable name and it's just an array. So let me print the array first. Let's understand what it is. And lum, and execute it, and this is what we got. Of course, in between you have a dots, that means it's a huge one. So let me check the shape of n dimensions. Lum image, lum img, and ndim, and execute. It's a 2 dimensions, so one dimension has been removed. So let me check the array property, one more property of this array, and I'll say shape 375 and 500, and it's obviously a 2-dimensional. And this, and total elements, let me check how many elements has been pulled out of it. It's size, oh, 1,87,500. Clear? So now let's print, because we have applied uh, we have applied. So look, we will print this now. So we have sliced an array, we have sliced this array with this index, and then we will plot it. So plt dot imshow image show, and lum, it's img, and this is what we got. Clear? This is how the contrast has been increased. Just compare with this and then this. It's far better in visualization and viewing the visualization when you're projecting it in projector. So now with this luminosity 2D, it's a no color image. The default color map is applied. So let me have more fun on the same image. So now with a luminosity, this image, so we can apply the default color map is applied. So the default is called Verdes. So there are plenty of others to choose from. So we will choose one now. So plt.imshow and lum image, and then cmap, the color map. I'm gonna go for this time hot. I'm gonna go for hot and execute, and this is what you'll get. Oh, it's pretty hot, but it looks good. That's okay. And the next one, we have gone with this color map of hot. So note that you can also change color maps on existing plot objects using the set cmap method. So now let's use set cmap method to the existing one. So we'll take this one, and img plot is equals to plt.imshow and lum image. So this is what we got. So now I'm gonna do the changes. I'm gonna change color maps on this existing plot object. So what I'll do for that, I have to apply a set cmap method. So take image plot, img plot, and then dot set, you see that, set alpha, set animated, set cmap method. And in argument, I will say nipy underscore spectral underscore spectral, and execute it, and this is what we got. Oh, looking beautiful, beautiful, amazing, magnificent. So there are many other color map schemes available. You can just look into the list and images of the color maps, and you can basically do a lot of experimentation. So with each experimentation, you can have more fun.